Good morning students. How are you beta? Fine. Okay. Last time we have find the refractive index of the glass slab. Today our aim is to find the refractive index of this prism. Prism has three lateral face, that is a rectangle shape, while the upper and bottom with the triangle shape. So first let me read the aim. To determine the angle of minimum deviation for a prism by plotting the graph between I and delta, and to find the refractive index of the prism. And formula for that is that refractive index is equal to sine of A plus delta n by 2 whole upon sine A by 2, where A is a prism angle. Here the prism is equilateral. So angle between two lateral face is equal to 60. So first observation is prism angle A is equal to 60. Now for that you will draw the typical figure from the manual book, which is here. Can you see this figure? Now let us start the first here. So we will suppose we have a prism. We will draw a normal. Say it is a normal and for this given incident angle I, this is the straight ray, but here the rays will deviate from its original path, and this distance, this angle is called a angle of deviation. This angle is I. So you have to plot the graph of I and delta, that is delta versus I. Let me decide the four different values of the incident angle, and which is equal to 35, 40, 45 and 50. For that let me find the angle of deviation. Then we will plot the graph. When the graph is turned from this point, so this point is called a minimum deviation angle. And when we substitute in the formula, you will get the refractive index of prism. Let me start the experiment. Let me first draw the outline of the prism. First place the prism here and draw the outline of the prism. Like this and this. Now remove the prism and draw a perpendicular from this surface. Say it is a normal. For that you will place the protector this side. The 0 should be on normal and 90 should be on prism surface. Now let me measure the angle 35 from the normal. Here is equal to 0, 10, 20, 30, 40 and here it is equal to 35 degree. Now draw a ray at 35 degree. Okay. Now fix two pins on this incident ray. Now fix two pins on incident ray. See, this is I is equal to 35 degree. So these pins are on at 35 degree. Now replace the prism on its position and observe from this line, this side, and arrange two pins such in a way the incident and emergent rays becomes collinear. Now from these sides, when you observe, this is emergent ray, this is a incident ray. Now incident ray and emergent ray is now collinear. So let me note down this point and also spin out this fourth pin, so that the pin P1, P2, P3 and P4 should be collinear. Okay, it will be not collinear, but it seems as a collinear. Here this pin 3 and pin 4 seems as a collinear with the P1 and P2. So this is a pin 3 and pin P4 is a emergent ray direction. Now remove the prism, remove the pins and draw this direction of this emergent ray and extend the incident ray in this direction, and also measure this angles, and let me measure the angle between incident ray E and emergent ray I and emergent ray E. This angle is known as a delta. Let me measure with the help of protector. Now the angle between incident ray I and emergent ray is equal to 42 degree. Can you see this 42 degree? So let me note down this as 42 degree. Now for the when I is equal to 35, the delta was 42. In the same way, when you place the prism, again repeat this experiment. For I is equal to 40 degree, you will get delta is equal to 39 degree. Similarly, for the two more readings, when the I is equal to 45, the delta will be equal to 40 degrees. And same for this, when the I is equal to 50 degree, when I is equal to 50 degree, the emergent ray will be delta will be equal to 44 degree. Now using this data, let me plot the graph on the graph page. Now when I is equal to 35, the reading is at a delta is equal to 42 degree. Now when I is equal to 40 degree, the delta is equal to 39 degree. When I is equal to 45, delta is equal to 40 degree, and when I is equal to 50, delta is equal to 44. Smoothly join them and draw a line. Then you can find the graph when it's written. So here the graph is written at 38 degree. So let me note down this reading in an observation table. So when you plot this line, draw a line here. So you will get here a 38 degree. So here you can say delta is equal to 38. So minimum deviation angle is equal to 38 degree. Let me plot in the graph and find the delta. We have already find the delta m. Now let me find the refractive index eta. Now let me note down this angle of deviation for the I. When I is equal to 35, the deviation angle was 42 degree. And when I was equal to 40 degree, the deviation was 39 degree. For the 45, it was 40, and for 50 degree, it was 43 degree. That means graph is turns bends from this and this degree. It was 38 is a minimum deviation angle. Let me substitute in the formula. So sin A plus delta m by 2 whole upon sin A by 2. A means 60 plus 38, it is 98 by 2. It is a sin 49 degree dividing by sin 60 by 2, that is sin 30 degree. Now from the natural sine table, so you can find the value of the sin 49 degree here, first column mein, and here Sin 49 degree. See, it is 0.7547. So 0.7547 dividing by sin 30, that is 0.5. So this by this you will get the answer is 1.5094, which is a refractive index of the material of the prism, and here the material of the prism is glass, so obviously its refractive index is 1.5. So this is a quite right reading. So students, please note down this reading in your journal and complete this experiment, and let me complete this experiment beta. Have a nice day. Thank you very much.